In this video, we're going to go over how to calculate pH, the concentration of hydronium ions, pOH, and the concentration of hydroxide ions. So there's a number of formulas here that you should memorize. So all of these formulas here, you'll need to memorize them because they are not given to you in the data booklet. Now, there are some little typos here. So for finding the concentration of hydronium, it should be 10 to the power of negative pH. So this should be superscript. And same for finding the concentration of hydroxide ions using pOH. It should be 10 to the power of negative pOH. So again, just making sure that that is superscript instead. All right, so looking at these formulas here, some important things to notice here is that for finding pH, you need to take the negative log of the concentration of hydronium ions. The most common mistake with finding pH is just to forget the negative in front of the log. Okay. Another thing that this formula tells us is that pH is correlated to the concentration of hydronium ions. So what that means is hydronium ions can help you to find pH, but they cannot help you find pOH. Okay. To find pOH, you need to use the concentration of hydroxide ions. So that's very important. And another note about this formula here to find pOH, again, the most common mistake is to forget the negative in front of the log. With our formulas for finding concentration of hydronium or concentration of hydroxide ions, similarly, the most common mistake is to forget the negative in the exponent. So just watch out for that. And this last formula here says that you can use pH to find pOH, or you can use pOH to find pH. Okay, so that's just some notes about the formulas that are on this page here, but you do have to memorize all of them there. Okay. So for this next section, you can read through it on your own here, but moving on here to the next page, we do need to talk about sig digs, because with pH and pOH, the rules are a little bit different than normal. Okay, so sig dig rules for pH or pOH compared to concentration or just any other number that isn't pH or pOH. But since we typically use concentrations either of hydronium or hydroxide ions when finding pH or pOH, that's why I'm comparing the two of those. Okay, so the easiest way to remember the sig dig rules for concentration versus pH or pOH is to think about the word concentration. So the word concentration does not have the letter P in it, therefore you got to look at the entire number to determine the sig digs that are in a value for concentration. However, for pH and pOH, because they do have the letter P in it, you could kind of think of it as pH or pOH you got to look after the point to determine sig dig. So you got to look after the decimal to determine sig digs for pH or pOH. So let's write out everything that I just said. So for example here, if we had a concentration of, let's say, 1.234 moles per liter, right, then that value would have 4 significant digits because we're looking at the entire number here to determine the sig digs of this value. Now let's write what I said about pH and pOH. Okay, so again for pH and pOH, because they have the letter P for sig digs, you only look after the point. So if we have an example here, so it doesn't really matter if this is pH or pOH, it'll be the same amount of sig digs, but just for giggles, let's just say that I'm talking about pH here. So let's take that same value, 1.234. Now remember, pH and pOH, they do not have units. Okay, but if we look at this value for pH, remember, because it has a P in it, you only look after the point. So by point, I mean decimal point. So this value, because it's pH, it would have 3 sig digs because those are the amount of significant digits after the point. Okay, so what it says underneath here is similar to what I just said. So remember that the only digits after the decimal in pH and pOH are significant. The number of sig digs in concentration is equal to the number of decimal places in pH or pOH. Okay, so we've got a few examples here of calculating pH, the concentration of hydronium ions. So this plus should be superscript because it's a charge. Same with the hydroxide ions, the negative should be superscript because it is representing the charge. So the example here, we're supposed to be calculating pH, the concentration of hydronium, pOH, and hydroxide ions, then determining if the substance is acidic or basic. as well as the number of sigdigs. So before we get going on this, I'm just going to write out the formulas that were on the previous page, just so we can see them while we're doing these calculations. So remember, pH, you need to use concentration of hydronium ions in order to find that. And the most common mistake that people make is forgetting this negative here. For finding the concentration of hydronium ions, you need to go 10 to the power of negative pH. And people often forget this negative here. For determining pOH, we take the negative log of the concentration of hydroxide ions. And again, most people forget about this negative. So basically, if you get a weird number for pH or pOH, most likely you've forgotten the negative. Okay, so concentration of hydronium helps you to find pH and vice versa. So pH helps you to find the concentration of hydronium ions, whereas for pOH you need to use the concentration of hydroxide ions, and vice versa. To find the concentration of hydroxide ions, you need to have the pOH value. Okay, and then last but not least, our final formula is pH plus pOH is going to equal to 14. So this 14 just represents that our pH scale goes from 0 to 14. And you know what? I'll write out the little note that I've said here before, and I've highlighted the negatives. Don't forget the negatives in these formulas, because you will get weird numbers if you don't put in the negatives. Okay, so let's get started with row A here. So we're given the concentration of hydronium ions, and this should be 6.345 times 10 to the power of negative 5. So that negative 5 should be written as an exponent. So if I'm looking here, this is a concentration that we're given. So we got to look at the entire number to determine sigdigs. Okay, so this number has 4 significant digits. So I'm counting 1, 2, 3, 4. Okay, anything in the times 10 to the power of whatever exponent does not get counted for sigdigs. So I'm going to write 4 sigdigs here. Okay, now for whether it's acidic or basic, I find it's the easiest just to figure out pH to determine that. That's the easiest way to determine if something is acidic or basic. So remember that anything below 7, a pH of 7 is going to be acidic. Anything above a pH of 7 is going to be basic. And right at 7, so it has to be 7.00 exactly, that would be something that's neutral. All right, so let's get into the calculations. So we have concentration of hydronium. We're looking for pH. So that means I'm going to be using this formula right here. pH is equal to the negative log of the concentration of hydronium ions. So negative log and then 6.345. Second function log to get the times by 10 to the power of negative 5, hit the right arrow to get out of the exponent, close the bracket, hit enter, so I get 4.1975. Okay, so for this, I don't have a whole lot of space here, so I'm going to report this in the correct amount of sigdigs. So because we need 4 sigdigs, and pH has the letter P in it, so I only look after the point for where the sigdigs are. So that means I gotta go 4 digits after the decimal. So that would be 4.1975. However, after the 5 is a 6, the 6 is gonna round the 5 up to a 6. Okay, so the sigdigs, I'm just underlining them to show you where they are. This is 4 sigdigs. Okay, so if you wanted to see my work, that would be negative log 6.345 times 10 to the power of negative 5. Okay, I had a little bit more room than I thought. Okay, but I'm only going to show my work for this first row here, but not for the other rows just because I don't have a whole lot of space. Okay, so now that we have pH, the question is asking us to determine pOH. So what I can do is I can use this pH plus pOH is equal to 14, but what I'm going to do is I'm going to subtract the pH over to isolate for pOH, since that's what we're looking for. Okay, so I'm going to use that 4 point, let's get the raw number up here. I'm going to use the raw value, so 4.19756 goes on forever. And I'm going to go 14 minus that raw number. So I get 9.8024 goes on forever. But since I know I need to put this to 4 sigdigs, and because pOH has the letter P in it, I'm only looking after the point to determine sigdigs. So this number will be 9.8024. So the sigdigs are right here. Now, since we have pOH, I can use that to determine the concentration of hydroxide ions using this formula here. So I'm going to go 10 to the power of 9.8024, and that number kept on going on forever and ever and ever. Okay, so if I go second function log to get the 10 to the power of, negative, and then second function answer, so I get 1.5760 goes on forever times 10 to the power of negative 10. So most people forget to write the times 10 to the power of negative 10. That's the most common mistake there. Okay, and I am going to report this in the correct amount of sigdigs, so 4 sigdigs. But because this is the concentration of hydroxide ions, the word concentration does not have the letter P in it, so I got to look at the entire number to determine sigdigs. So 1.576, that is 4 sigdigs, times 10 to the power of negative 10, and my units here are moles per liter. Okay, so what I'm going to add in here is just the units at the top of each column. So pOH and pH, they don't have any units. Okay, so I'll count what I've written in blue up here just for counting like my units for each of the columns here. Okay, Now, is it acidic or basic? So the easiest way to figure that out is just to look at pH. So looking at pH, it's 4.1976, so that's below 7, so it's acidic. So I'm going to say A for acidic here. Okay, so right now you have all the skills that you need in order to figure out the rest of the rows. If you wanted to go ahead and pause the video and work ahead on these questions, then you can definitely do that. So I'll give you a second to pause the video. All right, for the next row here, we've got 2 sig digs. Okay, so how I'm determining that is this 10.33, that's pH, so you look after the point. So 2 sig digs. To determine concentration of hydronium, I'm going to be using this formula here. So second function log 10 to the power of negative 10.33. Hit enter, so we get 4.6773, goes on forever, times 10 to the negative 11. But since we're only using 2 sig digs, what that means is because this is a concentration of hydronium, we're looking at the entire number because the word concentration does not have the letter P in it. So to report this in 2 sig digs, I would write 4.7 times 10 to the negative 11. For pOH, what I would do is I would take 14 and I would subtract it with 10.33. Okay, so very similar to what I did up here. Okay, so this is also in 2 sig digs. Okay, and then to determine concentration of hydroxide ions, I would go second function log 10 to the power of negative, and then the pOH. So that's going to be 2.1379, goes on forever, times 10 to the power of negative 4. So reporting that in 2 sig digs. Would be this. So there are my 2 sig digs. So whether it's acidic or basic, let's look at pH. So 10.33, that's above 7, so this is going to be basic. Okay, for the next 2 rows, I'm just going to quietly go through how I'm doing my calculations. So we got a pOH of negative 0.50. I'm just starting off with figuring out pH from pOH. So 14.5, because it's above 7, that means it's going to be basic. So for the concentration of hydronium in the last row there, you could either write it like this, so 0.00556, or you could write it in scientific notation, which would be 5.56 times 10 to the power of -3. The exponent is negative because our original number, that number is between 1 and 0. Because the pH is less than 7, it's acidic. And there we go. Okay, so for the next example, we have to complete the following statement. When the pH changes from 10.5 to 13.5, the acidity of the solution does what? Either increases or decreases. Well, since we're going closer towards 14, and we know 14 is a super basic substance, I would say that the more basic a substance gets, the less acidic it gets. So the acidity is going to decrease. And the hydronium ion concentration either increases or decreases. So if I write this out, so we got 10.5, 11.5, 12.5, and then 13.5. Okay, so as we get more basic, the concentration of hydronium is going to decrease, because hydronium ion concentration, that is related to, like, the higher the concentration of hydronium, the more acidic it is. The more basic something is, the lower the concentration of hydronium is going to be. So that means hydronium is going to decrease, or the concentration of hydronium is going to decrease. Okay, now by a factor of how you're going to figure that out is you're going to count how many spots or how many units you're moving over. So 1, 2, 3. So with a scale such as pH, it's a logarithmic scale. So anytime you change 1 unit, you are either increasing or decreasing the hydronium ion concentration or hydroxide ion concentration by 10 times. And whether you increase or decrease depends on what substance you're talking about, so either hydronium or hydroxide. And whether you increase or decrease also depends on if you're getting more basic or more acidic. So since we're talking about hydronium ion concentration, and because we're getting more basic, that's the explanation behind why it decreases, because we're getting more basic. So hydronium ion concentration must decrease, and it's going to be a factor of 10 times 10 times 10, which is 1,000. Okay, so I'm just going to say 1,000, or you could say 10 to the power of 3. Both work. Okay, so question 94, that's a practice question. So from here on out, it's more practice questions here.